Let's look at some practice problems on projectile motion. Kayla throws a rock horizontally at 12 meters per second from the top of a 45-meter high cliff. So the vertical height of our cliff is 45 meters. Kayla throws the rock horizontally, so all of its speed is in the horizontal direction to begin with, and we know that this velocity is 12 meters per second. How far will the rock land from the base of the cliff? So we would like to know the horizontal distance that the rock can travel in the same amount of time that it's falling. It's important to remember that the time needed for this rock to strike the ground is exactly the same as that of a rock which were dropped from rest 45 meters high. So if we can calculate the time that it is falling, then it can travel to the right at a constant speed of 12 meters per second for every second that it is in the air. So find the time needed for the rock to fall. So we're considering motion in the vertical direction only. It's accelerating due to gravity, and we know that vertically we can use the equation distance equals 1/2 at squared. The vertical distance that the rock falls is 45 meters. Acceleration due to gravity is 9.81 meters per second squared. Find the time. Alright, so if we rearrange the equation, multiply by 2, divide both sides of the equation by 9.81, and if we take the square root of both sides, then it would give me t. So the time needed for the rock to fall is 3.03 seconds. As the rock is falling, for every second that it's in the air, it can travel to the right at a speed of 12 meters per second. So in the horizontal direction now, we know that it's constant speed, and for constant speed, speed equals distance divided by time. The starting speed horizontally is 12 meters per second. That will enable us to find the distance that the rock travels from the base of the cliff. So multiply time, which is 3.03 seconds, times speed, and it will give us the distance. The distance that the rock lands from the base of the cliff is 36 meters. Practice problem number 2. Skylar kicks a football, and 2 seconds later, it hits the ground 37 meters away. What was the initial speed or the initial velocity of the football? So first, let's draw a little picture. The football is launched with some initial velocity, call it v, and it follows a parabolic trajectory as it travels through the air. It lands a distance of 37 meters away. So horizontally, the football travels 37 meters. The question is, what was the initial speed? What was the velocity that the ball was kicked at? Remember that this velocity will be at some angle above the ground. Also remember that any vector, any velocity vector here, can be broken down into 2 components: vertical speed and a horizontal speed with which the football is going up into the air. What was the initial speed of the ball? We know time in this problem, that the time that it took for the football to rise up to its highest point and hit the ground again was 2 seconds. In order to find the starting speed, first let's calculate what was horizontal speed. We're looking for launch speed, which is v. First, let's see if we can find VH. So horizontally, it's moving at a constant speed, and speed equals distance divided by time. So the horizontal speed, VH, is equal to the total distance the ball traveled, 37 meters, divided by time, which is 2 seconds. Vertical speed of the ball, horizontal speed of the ball is 18.5 meters per second. Next, we would like to know, what was the ball's vertical speed? Well, if the ball is in the air for a total of 2 seconds, then it means the time needed for the ball to rise up to its highest point before coming to a rest for just a second would be only 1 second, because the time needed to rise to the highest point is exactly half of the total flight time of the football. So if the total time is 2 seconds, time to rise up to a rest would be half of that total time. Half of 2 seconds is 1 second. If a football were dropped from that maximum height and it accelerated downward for just 1 second, then its final velocity would be equal to acceleration times time. Acceleration due to gravity is 9.81 meters per second squared. So if the football accelerated downward for 1 second, then its final speed before striking the ground would be 9.81 meters per second. Therefore, the initial vertical velocity must also equal 9.81. Now, to find the launch speed of the football, we know a horizontal component, 18.5. We know the vertical component is 9.81. So the launch velocity is the vector sum of these two velocities. Use Pythagorean theorem. V is equal to the square root of horizontal speed, which was 18.5, squared, plus the vertical speed, 9.81 meters per second squared. So the launch velocity of the football turns out to be 20.9 meters per second. Now, as a second part to this problem, at what angle to the horizontal was the football launched? If we want to know the angle, now we actually know all three sides of the triangle. So we could use any trig function that you would like to find this particular angle, theta. We know that the hypotenuse equals 20.9. We know the vertical velocity was 9.81 meters per second, and the horizontal velocity was 18.5 meters per second. I chose to use the tangent function. The tangent of an angle theta is equal to the opposite side over the adjacent side, or in this case, it would equal 9.81 divided by 18.5. So if we use the inverse tangent, we can find the actual angle itself. When you divide 9.81 by 18.5, the result turns out to be 0.5303. So the inverse tangent of 0.5303 would be 28 degrees. So angle theta, the angle that the football was launched at, would be a 28-degree angle. Another practice problem. Adam is skateboarding across the gym floor at 5.5 meters per second when he throws his keys straight up relative to himself at 7 meters per second. How far has Adam moved across the floor when he catches his keys again? Alright, so we have a starting vertical velocity of 7 meters per second. We have a horizontal velocity at which he's skateboarding of 5.5 meters per second. And we would like to know At what distance across the floor will Adam catch his keys? First, let's find the time to rise up to a rest. I can use VF equals AT and substitute VI in the place of VF because it's coming to a rest rather than falling from rest. And of course, the initial vertical speed of the keys here is labeled as vertical velocity in my diagram. So we would substitute 7 meters per second in the place of VF. Acceleration due to gravity, or deceleration due to gravity in this case, is 9.81. So solving for t, 0.71 seconds would be the time needed for the keys to rise up. Now, we must double this time because the keys rise up in the air, of course, and then come back down again, an equal amount of time. So if we double time, the total time that the keys are in the air would be 2 times 0.71, or a total of 1.42 seconds. If we know the total time the keys are in the air, then horizontally we can calculate the distance that the keys travel. Horizontally, speed equals distance divided by time. Adam's speed is 5.5 meters per second horizontally. The total time that the keys are in the air, 1.42 seconds. So if we cross multiply the distance that Adam travels, it turns out is 7.8 meters. Let me correct that mistake here. D equals 7.8. Now I have some practice problems for you to try. See if you can find the answer, pause the video, and when you're done, press play so that you can see the answer. Here's practice problem number 1. Pause the video. Now here's the answer for practice problem number 1. Practice problem 2. Pause the video, and when you're done, press play to see the answer. Here's the answer to the second practice problem. Here's practice problem 3. Pause the video, and when you've worked it out, press play to see the answer to this practice problem. Here's the answer to practice problem 3. Of course, there are many variations on projectile motion problems, so the instructor will give you additional worksheets and additional homework to help you practice as much as you possibly can prior to having an examination on this topic.